Students, the next sum, page number 11, 8th question. Find the HCF of the numbers 441, 567 and 693 by Euclid's division algorithm. So far we have seen to find the HCF of given two numbers using Euclid's division algorithm. Now we are going to solve for three numbers. This is nothing different. First we have to pick either the largest two numbers or smallest two numbers. Okay. So we have to find the HCF between those two numbers using Euclid's division algorithm. We will get an HCF, and with that HCF we have to combine with that third number, the HCF of two numbers and the third number. So apply Euclid's division algorithm to HCF and the third number. Then we will get the final HCF of the three numbers. Okay. Here I am taking the smallest two values. Okay. The smallest two values between 3 are 441 and 567. So I am going to apply Euclid's division algorithm to these two given positive integers. Okay. According to Euclid's division lemma, A is equal to B into Q plus R, where R can take the values between 0 to less than B. Okay. Here I have to substitute the value of A to be larger number and the value of B to be smaller number. So I am taking, in first I am taking A is equal to 567 and B is equal to 441. Okay. So it becomes 567 is equal to 441 into some quotient value plus some remainder value. We have to find the values of Q and R. So dividing the number 567 by 441. Okay. I will get a quotient 1. Subtracting these two numbers, 6 here to 1. So I am getting 126 as remainder. So 567 can be written as 441 into quotient value 1 plus remainder value 126. Now in the second step, this 126 becomes the divisor and 441 becomes the dividend. When dividing these two numbers, 126 into 3, 18 balance 1, 7, 3, I am getting 378. The quotient here is 3. Subtracting these two numbers, 3, so it is 63. I am getting 63 as remainder. So 441 can be written as 126 into quotient value 3 plus remainder value 63. Okay. So in this step 63 becomes the divisor and 126 becomes the dividend. 63 into 2 gives 126. So I am getting the remainder value 0. Then 126 can be written as 63 into 2 plus 0. So remainder value gets 0. We have to stop the procedure to find the HCF of these two numbers alone. So I am finding the HCF of these numbers to be 567 and 441 is 63. The last obtained B value. Last obtained B value is 63. In the second step of this solution, the HCF of these two numbers is 63 and the third number is 693. So I am going to find the HCF of the numbers 63 and 693. Okay. Then A takes the larger value, it is 693. B takes the smaller value, it is 63 into some quotient value plus some remainder value. So dividing the number 693 by 63, here 63 goes for one time, 3, balance here is 6, so it also goes for one time, remainder is 0. So it is entered in single step. I can write 693 as 63 into 11 plus remainder value 0. So, the last obtained B value here is 63. So, the HCF of the numbers 63 and 693 is also 63. So, the common HCF between these three numbers 441, 567 and 693 will be 63. It is the highest common factor between these numbers. In first step, these two numbers will have HCF 63. In second step, 63 and 693 will have the HCF as 63. So, the combined HCF becomes 63. Okay. So, 63 is the HCF of these numbers. Students, the next sum, page number 12, 9th question. Find the largest number that divides 1251, 9377 and 15628, leaving the remainders 1, 2 and 3 respectively. So, I have to solve this using Euclid's division algorithm. See here, these numbers are getting divided by some number, okay, some common number. So, it leaves the remainder 1, 2, 3. We have to find that divisor, highest common. So, we have to find the highest common factor between these numbers after subtracting these numbers by 1, 2, 3 respectively. So, solution 1251, 9377 and 15628 leaves 1, 2 and 3 as reminders. When divided by some number, okay. So, I have to find this number. This number is nothing but the highest common factor between these three numbers. So, first we have to subtract 1251 minus 1 gives 1250. We are subtracting because it leaves these reminders, right. So, I am going to subtract those values. 9377 is subtracted by 2. So, it becomes 9375. Then 15628 is subtracted from, so 3 is subtracted from 15628. So, it becomes 15625. So, you have to find the HCF of these three numbers using Euclid's division algorithm. So, to find HCF of the numbers 1250, 9375 and 15625. Okay, we are going to apply the Euclid's division algorithm. As usual, take the two smallest numbers, it is 1250 and 9375. So, according to Euclid's division lemma, the condition is A is equal to B into Q plus R. So, the A and B, substitute the value of A and B. A takes the larger value, here A is equal to 9375 is equal to B value 1250 into some quotient value plus some remainder value. Now, we are going to divide these two numbers. It is 1250. So, 1250 into 4 becomes 5000. Let me try 1250 by 7, 0, 35, balance 3, so 17, balance 1, 8. I am getting 8750 for the quotient 7. Okay, so subtracting these numbers 5, 2, 6. Okay, so it is 625. I am getting the remainder as 625. So 9375 is written as 1250 into 7 plus the remainder value is 625. So, in the next step 625 becomes the divisor, 1250 becomes the dividend. 625 into 2 gives 1250. So, the remainder becomes 0. Now, I can write the number 1250 as 625 into 2 plus 0. So, remainder is 0. I have to stop the procedure here. So, the last obtained B value is 625. So, the HCF of the numbers 1250 and 9735 is 625. Now, we have to find the HCF of these two number gives 625 and the third number is 625, the subtracted value is, okay. So, I am getting the subtracted value as 15,625. You have to find HCF of these two numbers. Again the condition is A is equal to B into Q plus R. A is 15,625 and B is 625 plus into some quotient value plus some remainder value. 15,625 is getting divided by 625. So, 625 into 2 becomes 1250, here 1250, quotient is 2. So, subtracting these values 2, 1, 3 and drop down this, it is 5. So, 3125. Let me try 625 into 5. 5 5s are 25, balance 2, 12, balance 1, it is 3125. So, I am getting 25. So, the number 15,625 can be written as 625 into quotient value 25 and the remainder value to be 0. So, I have to stop the solution. Here I am getting the last obtained B value is 625. So, HCF of these two numbers 625. So, I can conclude that the HCF of the three numbers 1250, 9375 and 15,625 is 625. Okay. So, the conclusion is that when these numbers are divided by 1251, 9377 and 15,628 or divided by 625, it leaves the remainder 1, 2 and 3 respectively. Okay, so we have found that number, right? That is 625. So 625 is the largest number that divides 1251, 9377 and 15628. So that it leaves the remainder 1, 2 and 3 respectively. So the largest number here is 625.